Okay, welcome to Chapter 8 land. All right, so Chapter 7, we talked a lot about work, right? And so now what we're going to do is we're going to use what we know about work to launch ourselves into Chapter 8 and then discuss stuff on energy, right? So this is going to really give us a big tool. All right, so there are two types of forces, right? We're just going to define them, right? So we're going to say that there are two types. There's the conservative forces and the non-conservative forces, right? So this is just a definition, right? And so it turns out that it's this really nice mathematical definition. That if I want to know what the work is around a closed loop for a particular force, it's equal to 0 if it's conservative, and it's not equal to 0 if it's non-conservative. Whew, that's easy, right? Brilliant. How hard can that be? All right, so first off, you've never seen one of these things probably before. What does that mean? It means around a closed loop. Okay, so imagine going in a circle, right? I start at one position, and as I go around the circle, I come back to the exact same position, right? I go around a loop, right? So if I add up all the work that's done in that system as I go around that loop, it'll add up to 0. If it's a conservative force. It doesn't depend on the path, right? Whereas a non-conservative force will have a different amount of work depending on how big my circle is. So if I go around a little circle, then I get a certain amount of work. But if I go around a big circle, I have another amount of work that's being done, right? So I get a different value for the work. All right, so let's do two case examples for how this might work. All right, we're going to go through a very simple path. We're going to go down and up. Try that again. Down and up. So what we're doing is we're just going to look at the work done by the gravitational force. All right, so let's do the down part. Okay, so I have my force, mg, which points down. Gravitational force is pointing down. And I have my path, which is also pointing down, right? Because I'm going down the path. So I do the dot product between a force that points down and a path that points down, the angle between them 0. And I get the work done here is mgh. Okay. So, but that's only halfway around our loop. We want to come back to the top, right? So we do up. What's the work done there? Well, now my force of my gravitational force is still pointing down, but my path is now going up. So now I take the dot product between a force that points down and a path that points up. There are 180 degrees between them. The work gives me minus mgh, right? So I add them together. Mgh minus mgh gives me 0. It's independent of the path, right? So no matter how far I go, if I come back to the same point, I always get 0, right? So that is a huge point. With conservative forces, it's not dependent on the path. Okay, cool. So what's an example? So, gravitation. Okay, so now let's look at a non-conservative example. All right, imagine I have a block, right? And it is moving in the following direction. It goes from point A to point B, right? And I ask, okay, while it's going, what's going on with the friction? If it's sliding along here, then there's a coefficient of kinetic friction, right? So if I draw the free body diagram, if you're mg, your normal force, and then you have your frictional force. So the frictional force is just mu k times the normal force. Here the normal force is just the gravitational force, and you get that the frictional force, it's minus, of course, minus mu k mg. Okay, so if I'm going from point A to point B, right, my path points this way. And my frictional force points this way, right? So they are exactly 180 degrees. So you get a negative amount of work done by friction as it moves from point A to point B. So then let's go over to point B, right, and go back to A. Well, when I do that, my velocity is moving in this way, and now my path goes this way, and my frictional force goes this way. And again, they're 180 degrees apart. So I get a negative. So when I add the friction from going from A to B, I get a negative. And when I add a friction from B to A, I get a negative. Right? And these are non-zero numbers. Right? So the total amount of work has got to be a negative. A negative plus a negative gives me a negative. Right? And so the farther it goes, right, the more work friction is doing. Friction depends on the path. Cool beans? All right.